Hey guys, this is explaining how to balance, write, and classify chemical reactions. What we're going to do is we're going to work on the front side in this first recording, and then in the back, or in the second recording, we're going to do the back side. Alright, so let's go ahead and get started. This is 12-4 homework. And our goal is to figure out, we're going to first start by balancing, and we're working on number 1. So if we look at number 1, we've got 2 H's on the reactant side. Just as a quick review, the left side is the reactant side, the right side is the product side. And so we've got to get the same number of atoms of each element on each side. So if we have 2 hydrogens here, we need to get 2 over here. The only way we can do that is by putting numbers out front. So I can put a 2 out front, but that gives me 2 H's, but it also gives me 2 Cl's, which actually works out for us because we have 2 Cl's there. So this one is balanced if we put 1, 1, 2. The type of chemical reaction that this is we have, if we switch gears just a little bit, we have one product. The type of reaction that forms only one product is called a synthesis reaction. So this is synthesis, and that's because we only have one product. If we go to number 2, we're going to work the same way. Remember, we're trying to get the same number of elements, same number of atoms of each element on each side. So if we just start with the first one we see, Al, I've got 1 Al here and 2 Als there. So I need 2 Als on this side. So I'm going to do that by putting a 2 there. Now we keep rolling. We want to save O for last. So we keep going. We get to Fe. I have 2 Fe's here. I only have 1 there. So I'm going to put a 2 out front there. And last but not least, we've got O's. Let's hope they're balanced. We've got 3 O's there, and we've got 3 O's here, so we are balanced. So to finish this, we can put 1's there, or we can leave the 1's off. Remember, they're understood. Switching gears. Typing, or what reaction type is, if we look here, we have an element plus a compound, and then on the other side, we have the same thing, compound plus an element. If we look through our notes, that tells us that we have a single displacement reaction. Alright, back to balancing on number 3. If we split up the reactions here, we can just go ahead and start with PB if we want. PB, we have 1 PB and 1 PB, so our PBs are cool. If we keep working left to right, we have 2 of these acetates on the reactant side, but only 1 acetate on this side. And since they stay together, I recommend that we balance them together. So we're going to go ahead and put a 2 out front here, which we'll get back to the H's in just a second. But let's go ahead and do S's as well. 1 S here, 1 S there. So we're good. So if we double check our H's now, we have 2 H's there because of that 2 right there. And we also have 2 here, so this is actually balanced. So all we have to do is put 1's in front of it, and we're good to go. Alright, switching gears. Type of reaction, if you look here, we have a compound plus a compound, gives us a compound plus a compound, which is a double displacement. Alright. If we keep rolling to number 4, we've got, if we start with the balancing portion, we have 2 Li's and 1 Li. So if we try to fix our Li's first, we've got 2 there, and so our Li's are good. We go back to our O's, there's only 1 O on this side and 2 on this side. So we're going to have to fix that, and we fix that by putting a 2 there. But that changes our Li, and now we have 4 Li's, so we can't have that 2 there anymore, and we need to make that a 4. So if we go back and check, now we have 4 Li's, 4 Li's, and 2 O's and 2 O's. So we are actually balanced here. If we switch gears to typing, we have one reactant breaking down, and so that is a decomposition. So we know it is decomposition because we only have one reactant or one substance on the left side. Okay? Everybody good with that? Awesome. Let's keep rolling. If we look at number 5, going back to balancing, go ahead and start left to right. We have 1 Na, 1 Na. So far, so good. We have 1 I, 2 I's. Well, we have to fix that, so we're going to put a 2 out front. That gives us 2 I's, 2 Na's. So let's also fix our Na's at this point as well. And now we have 2 Na's and 2 Cl's. To get 2 Cl's, hey look, we're already there. So we can put a 1 there and a 1 there. So this one is now balanced. If we look at the type of reaction, we have a compound plus an element gives us a compound plus an element. So this is a single displacement reaction. And you could just put single if you want to, that's alright. Okay, let's roll on to number 6, 2 more, and then we'll call this video good. So, if we work again left to right, remember we're trying to get the same amount of atoms on each side. So we've got 1 Mg, 1 Mg. So far so good. We're going to look at NO3 as one entire thing because it's a polyatomic ion and it stays together. And so over here we have 2 NO3s and over here we only have 1. So we've got to fix that. And we can fix that by putting a 2 out in front of the KNO3. But that also gives me 2 Ks. To fix this, I'm going to put a 2 in front of that K. And then that gives me 2 OHs. I'll put a triangle around this one. And if you look over here, we have 2 OHs on this side. So we are balanced, and we leave that with a 1 and a 1. Okay? Awesome. Now, type of reaction, if we go back, we have a compound plus a compound gives me a compound plus a compound. So that would be a double displacement reaction. All right, let's work the last one here. We have C3H6 plus O2 gives me CO2 and H2O. So in this one, we're going to start with carbon. Then we're going to do hydrogen, then we're going to do oxygen. All right, that's our plan of attack. We have 3 C's on this side. To get 3 on this side, we're going to put a 3 in front of the CO2. Now we're going to go back and balance our H's. We have 6 on the reactant side, and we need 6 on the product side. So to get that, we're going to put a 3 out there because 3 times 2 gives me 6. Now we check out our O's because we've done C's, we've done H's, now we're on to O's. 3 times 2 is 6, plus those 3 gives me 9 O's. Unfortunately, we cannot use halves right here, so we have to do something. This is where we get in trouble, and so our goal, or our ideal, is to double. So this was assumed to be a 1, so we're now going to make that a 2. This 3 in front of the CO2 is now going to become a 6, and that 3 in front of water is also going to be a 6 because we got in trouble. Now if we go back, check our C's. 2 times 3 is 6. We've got 6. 6 times 2 is 12. 6 times 2 is 12. So we're okay on H's and C's, so let's finish with O's. We've got... Let's kind of erase some stuff here. We're getting a little out of control with how much stuff is on here. We have 12 O's there and 6 O's here, which gives us 18. What times 2 gives us 18? That would be 9, and we're balanced. And our last step is to figure out what type of reaction this is. And this is a combustion reaction. Alright, see you in the next video for the backside.